You take the blue pill, the story ends, you wake up in your bed and believe whatever you want to believe. You take the red pill, you stay in Wonderland, and I show you how to make this amazing Matrix-style rain code effect. Let's get right into it. I think the first thing to be stated is that this tutorial is for folks that are a bit more comfortable with the idea of using geometry nodes inside Blender and with the process of using shaders. So this isn't necessarily for people who are beginners with the software. That being said, if you just follow the steps that I give, copying me step by step in this process, then you will be able to achieve the results. In order for the result of this to look exactly like the movie, you're going to need to download the free font. I have put a link in the description. Just wanted to go through conceptually what we're going to be making here. First of all, we are using geometry nodes, going to be making a line, and then we're going to be on that line, obviously, which has a load of different points on it. We're going to be displacing those points up and down, so you're going to have dot 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 and some in the middle. They're going to be displaced. Once we have that on each of those lines, we are going to be also generating more lines, which means we're going to end up with lots of lines moving downwards in a 3D space. That's the general consistency. On each of those points and those new lines, we're going to be generating the symbols that are used in the matrix style code, and from there we'll then animate it using predominantly the shading functions, although there are a couple of functions we're going to be passing through from the geometry nodes. This effect is a combination of a few different ideas that I've seen across the internet from fellow creators and things like that. I wanted to give my own spin on it, and that's where we're going to be setting off from. Okay, with that being said, let's kick off this properly. Let's first of all create a new plane. This is going to be just our placeholder object for our geometry nodes items, so it can really be anything, doesn't have to be a plane, can be the default cube if you like. I would personally rename this to something like raining code or raining underscore code, just so you understand that it's a bit of a placeholder. At the top here, you then want to go to geometry nodes and you want to press new, and you can again rename this to raining code or whatever you like, just so it's obvious, and you can rename the modifier as well, just to keep everything neat. If you do a shift tab button combo down here, you'll find that things are then snapped, which is kind of useful. So what we're going to be doing is deleting the input geometry, because we're not going to be using the plane that we have. We want to be using our own geometry that we're going to be bringing in. Now, just something to bear in mind, this is quite a lengthy process. I'm going to be splitting up this into several chapters. Feel free to use the chapters in the description to zip to whichever part takes your fancy. But it is going to go through every part of the process, and I'm basing most of it off my previous attempts at this process, so we're going to get a nice result out of this. So first of all, the basis of all of this is a curved line, the first of many. So if you do Shift A, bring that in. Again, we could just pass this straight to the output just so we get a visualization of what we're going to be doing, but it's not entirely necessary if you're just following along. We're going to need a lot of space in the future, and we're going to need to organize ourselves. So we want the points of this line to go in an X direction. So in order to do that, what I used before was a -5 on here, -5 on the start point, and a +5 on the end point, and you end up with something like that, and we don't want anything on the Z. So we have just literally a straight line with a load of points on it. not particularly exciting thus far, but bear with me. What we then want to do is kind of define along this how many points we're going to have, so we can effectively change the resolution of our product. Again, higher resolution will cost more in terms of computing efficiency. So what we can do to do that is use a relatively new node in geometry nodes, which is called the resample curve node. Using this, we can actually change the number of points that are on this line to something like 200. We want high resolution, so at the moment there are 200 points along this line, going from -5 to +5 on the X scale. We're then going to displace that. As I said, we're going to be moving things up and down. We want to displace that. We use the set position node in order to do that. Push that in there. We then don't want to offset everything. We want to be offsetting a random amount on the Z function. So up and down, with a majority still being in the middle. But again, because we're using geometry nodes, that's relatively simple to do, and we can change it over time. So we bring in a random value node, which we're going to set to Boolean. Again, 50% of the points on here are going to be displaced. So we take that value, put it into our selection. That means take every single point, and 50% of the time select that point to be offset by a certain amount. So if we pick just a set amount, 2.3 meters, 50% of the time a point is going to be moved 2.3 meters up. But we actually don't want that. We want the movement to be also random. So we need to bring in Shift A again, another random value, which we can put down here, perhaps, just making sure that we're organizing things. It's going to get complicated. We want that to be a float, and initially -10 being the minimum and 10 being the maximum. That gives us a range of 20 of our value. And in order to just target Z, which is what we want, we need to use a combine X, Y, Z node to pump this into the Z, which gives us a vector, which we put into the offset, and bam! What we end up with is a line where each point, 50% of the time, a point is moved up to a minimum of -10 or a maximum of 10 on our Z scale. So that's how we end up with 3D space. And what we're going to do from here is make more lines on each of those points going the other way. So across space we will get a nice amount of lines both in the foreground and the background of our finished product. When you're working with points on a curve, the basis of using those points effectively is an instance on points node. Pop that in there. Again, everything disappears. Our points still exist, but at the moment nothing is on those points, therefore we're not using them. So what do we do from there? Well, we can again bring in, like at the beginning, a curved line. This curved line is slightly different. What I've done before, again, mess around with these values if you want. I've done it from around 3 to -3, just to give a little bit of variance in there. And again, I have done a resample curve node, so we can just push on that one, press Shift D, bring that over here, and the count on this one is around 50. Again, these values are not set in stone. You can pick whatever you like. It's just I happen to pick what works for me. And as you can see, we have a great deal of lines in the middle, half of them, and the other half are spread around on a Z axis, and that gives you your depth. When your camera is looking from here, that gives you your depth that we can use for some artistic value in the last parts of our process here. Now the last thing we can do here, just to give a bit of variance, is another random value node. Again, we want a minimum scale of 1 and then up to 5, just to vary the length of these items, and you end up with a nice little distribution here. Again, the seed can be changed. The initial seed is actually rather uniform in its approach, but you can change that up just to whatever you like. Gives some nice variance of those lines where we're going to be deploying all of our symbols and then animating using the shading nodes. So just before we start the next part of the process, what do we need to do? Well, all of these points are not exactly usable at the moment, they're just sitting there. They are instances, so each of these curved lines, each of the points on the curved lines don't actually exist for usability by anything else. What we need to do is realize those instances, and again that's American spelling of realize there, but that's what we need to do. So that kind of brings those into actual usable geometry. Again, we could look to slightly change the what I've done here is another resample curve, but this time set to length. And that just means when we're looking to use these for other outputs, we're not getting quite as much geometry. We need to define the number of points that we're going to be using on the output per each instance, as it were. So from there, the last thing we need in order for animation to work is a spline parameter. Again, quite a new node. I will kind of go through, it's a little bit conceptual in the way this is going to work, but essentially before we start animating, before we start moving things around, we need to define a couple of variables, and that's what this kind of looks like. We need the factor, which is how far along we are. So the factor we're going to use to essentially move along each point in a set amount of time. I'm going to go 1, 2, 3, 4, 5, as it were. And also we're going to be using the index, which is essentially assigning each of these points along these lines a number, and using that number to animate. So as we move along the factor, as we shift along this line, that index is also going to be increasing, and we use that to define parts of our shader, which I'll be showing you next. So in this interest of keeping things neat, we're going to highlight all of this and press Ctrl J, bring that into its own frame for nice organization. We could make it a group if we wanted to, but just for the sake of this, we're not going to do that. The nice thing is we can change the color, so we can make it green, teal. Let's go with a teal, fine, turquoise, something like that. We can also give it a label, so this is just the creation of curves. So again, that kind of boxes that nicely. You don't have to think about that anymore. The things we're going to be outputting from here, from this frame, are going to be the factor, the index, and the resample curve, this actual geometry here, which is what we're currently seeing on the screen. We don't necessarily need to have all of this spreadsheet here, but it does give us an insight into how many splines we have and how many points we have. And this right here is the index, and this gives the position as a vector. It's quite useful. Keep it active if you want. I personally don't want to, because I'm not interested in the nitty-gritty numbers. So the next thing we need to be doing, prior to defining some of our animation, is to capture a couple of factors. So we need to be capturing an attribute. Not just once, we need to be doing it twice before they change. So it's quite important to capture these things before we make any changes to them over time, which is what we're going to be doing. So our first attribute is a float, and it is the factor. So we want to capture that. And our second is the index. After that, our geometry should... Let's do a nice little reroute here, because that's what I did before. So that keeps it nice and easy. Again, we could group these two if we wanted to. It's just purely capturing two items in order to get those items understood and defined for use later on. What we then need to do is start to define how the animation is going to go. So if I bring this back to our output, as I said before, each of these points has numbers assigned to them. We want to iterate on those numbers, pick each one, take its value, kind of store that value, and then as we move along, the new values that we are picking up on the new points as we go down the line, we want to be animating in a certain way using the shaders. So the way the shader works is each point that is picked, it's going to go white initially, and then it's going to fade to green, and then finally it's going to fade to transparency. So in order to do that, each of the points has to be selected, and then we move further down the line as we go on. That's what this next part of the process is. Again, conceptually kind of a little bit tricky, but it kind of makes sense once we get to the shading part, where each second we're going to be going down each of these points, and when we're on a selected point, it's going to be glowing white in our shader, and then finally fading to green or whatever color we choose, and finally fading away. So let's start that process. So the end part of this new box is a sample curve where we just need a couple of values to come out of it for later parts of the process, including scaling. So that's nice to store away later. But this initial bit, we also need to... Wait a minute. We also need another reroute here, which is going to be useful later on. And we also need... One thing I've just forgotten is we need to actually use these attributes effectively. The one we're actually interested in is this factor of the sample. That's the one we're interested in. So we want to pump that into a map range node from 0 to 1 to 0 to 1. So we effectively want to clamp it. What we're going to be doing there is then bringing this over to our value, and that should rather nicely bring everything for us. So what do we then do from here? We have taken the index before, so what we're going to do is just recover that index before we do anything. We're then going to get something called the domain size, which effectively tells us at the moment, if we pump in our geometry, how many points, what point are we on that scale? On that line that's going across, what point are we on? So we're capturing that. We got the index, and what we then need to do is a little bit of maths from there. So we're going to divide. We are going to divide the index by which point it's on. So where is that point? And then we take that. We then want to do some more maths over time. So we want to take a scene time. So every second, more maths, we're going to be adding the seconds. And what I did before, what I found was 5. We also want to slow this process right down. If we take it as it currently is, it is going to be very, very, very quick, and we don't want to do that. There are other ways of slowing this down. This is the way that I found works. we're going to divide it by minus 2000. Is that right? Is that what I did before? Yes. We then want to take that process of the index and the domain size point, and we want to add those together. So this is going to be a very small number added to where it currently is, but that number again is going to change over time. So as the seconds add up, it's effectively going to move along those points. Bam, 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 bam. Each point is going to change. Again, we fraction it so it can keep going forever. You can't just search for fraction, you have to go math and then fraction. Where is fraction? Fraction. Pump that into a fraction. And then we put that as the factor. We want all curves being selected. So again, this sample curve gives us, if we just pump this as the output, it's going to give us a value over time, kind of a summation of all of this, that can then be taken and used later on in the shading. So it's just a value that's going to be changed, but it represents how far along we are along each spline, along each curve, and we go from there. So again, we can group this into a nice frame. So J, and this can be spline values defined for scaling. That's quite long, but useful. Again, give it a color if you want. Yellow, why not? Let's keep things nice and neat. So now we need to take this value and this geometry, because our geometry is still live here, and do a little bit more with them. So the next step in our process is to bring this value down. Again, it could be alongside, it could be down, it doesn't really matter. And we just want to reroute that just down to there for now, just to leave it. And again, we want this one to come down here. And let's do a nice reroute. Now here is where I defined another sort of subgroup to start tinkering around with things. Let's start that process here. So we want to take all of our points, so all of these points going here, and we want to put each of the items from the matrix code on each of those points. You can use any font you like, but if you use the matrix font, it kind of makes sense. It makes sense in the aesthetic. So instance on points is another node that we've used before, but we need it again. So those points are now going to have instances on them. And just so we can visualize, I'm going to plug that into the output. So again, we get nothing until we define what we're going to be doing. So string to curve is how you get words going on in your instances. So you want essentially the entire alphabet plus symbols, more or less, as many letters as you want, plus all of that stuff in there as your instances. And this is probably going to actually crash my computer, or not quite, we're there, it's okay. I should have thought about this before I did it. So let's cut that, otherwise we're gonna crash, and that would not be very good. So be careful at this point, because you'll end up with far too much on your screen, in your memory, and it will definitely crash your machine if you're not careful. So what we then want to do, we have string to curve, so it's going to take all of those items. You want to define your font, so you want to go download that font if you haven't done it already, install it. I haven't had much luck actually installing it on my computer as a font to be used in other bits of software. That didn't really work for me. yeah, as you can see, it's not actually installed itself. So what you can do is download it, go to your downloads, make sure you unzip the download first. It will come in a zip format. So make sure you unzip your download. Then what you can do is go to that download. And yeah, matrix code. Pick it, and that will be selected there. What we then want to do is make sure it's set to center and middle for both of those, and our pivot point is going to be the midpoint. Our sizing is going to be very small, 0.001. We're going to have 0 on the character spacing. We want no spacing between the words, we want no spacing between the lines, because we're just putting it one letter at a time onto our points. So we then want to take another relatively new node, the fill curve. So we're converting our instances, our curves, into n-gons, into geometry. And again, we need to do another random value. And this is going to be an integer, so this is what I did before, 1 to 100, 0 to 100. Put that into the instance index, pick an instance, which means for each point, don't put everything, just put a random part of the code onto that point. And there we go. So what we end up with is little tiny bits of the code here. Now we actually want to pump up that scale. There we go, that's more like it. So we end up with tons and tons of matrix style code in actual geometry in our scene. Again, you could have used a scale instances node, but you don't necessarily need to. The random value has a seed. We want to change that seed over time. So we want to take scene time. We've done this before, but this time we want to take the frames, the current frame that it's on, and we want to slow that down by, I picked 6 before because that's quite good, and then you just put that into the seed. And that means if we press space to begin, every 6th frame, it's going to change the actual output of the code. So not only are we going down each spline, defining stuff for our shader, we're changing the actual letter displayed from this list defined earlier. Now what I would tend to do at this point is make this into a new frame. You could group it if you wanted to, but you don't necessarily have to. So what we have is our instances, and we want to scale those instances, but they're going to be scaled over time by this sample curve value. As it goes down the curve, the scale gets smaller and smaller. That's what's going to happen over time as it gets smaller, eventually effectively disappearing. So we're going to plug that into our scale. And what that means is we have things appearing and disappearing over time, which is a lovely effect. We're starting to get things together in a way that starts to make sense for people, which is really useful. At this point, we're now going to define our material. Let's call it rain, because we're doing raining code, as you can see. So we want to also store an attribute, a named attribute. It is a point, float instance rather, and it comes from this particular value here, which again increases over time, and we want to call it alpha because it's the value that defines when something is going to be disappearing from our view. So as these things trail off, as they get smaller, they eventually disappear when the trail gets there. We're just defining that ability now. We also might want to delete some of this geometry if it's getting too heavy for us. Again, this is what I did before, but it could make sense to do it now. We want a random boolean again. If this seems a bit floaty, this tutorial, I do apologise. It's more in my head than anything else, but we're getting it down there, and hopefully it's useful to some of you. It's quite a fun little experiment anyway, and maybe it can be applied to lots of different things. So what do we do from here? Yeah, we could delete some geometry. What I actually set up before was 2 different lots of these instances, and deleted half of them and then deleted the other half with the other set, so you had essentially 2 different lots going down, which gives a bit of variance. Not strictly necessary, but here we are. So let's join that in a frame, and finally there's last 2 outputs before we start shading, before we start creating our shading, is to store named attributes. So we need to define 2 things for our shaders, and this is effectively where we get the front and the back, so the back being green and the front being white of our code. You know how it fades from white to green usually, or any colour you like, so we're going to define a colour for both of these, and we're going to call this one the front. It's just so we can pick it up on the shading side, and this one's going to be called the end. This one is going to be white. This one I will just copy the value I used before. I'll put the hex code on the screen for you lot, but if you're interested, the hex value is that. Gives us a nice healthy green. Again, change it to whatever you want. And I believe, thankfully, that is the last of the geometry nodes that we need to be doing here. And we end up with a rather large geometry nodes tree, but hopefully it makes sense. Essentially, as we move down, as we go over time, each point gets selected, and if it's at the front, it will be defined with white, and it will move down to the next one. As it moves down, the previous one gets green and eventually scales down to 0 and gets taken out by the alpha value here. I'm just going to double check I haven't missed anything from my previous attempt at this, and it looks like I've covered everything. So now we're going to move on to shading. We got our rain material set up, and again, it's not too difficult to do this, but let's take the shading workspace. Again, it might go a little bit funny on you. Let's just have one object mode at the top. Again, this will work in Eevee or Cycles. I prefer using Eevee, it's quicker and it's going to be absolutely fine. You might want to turn off motion blur. You could add a bit of depth of field, but we can do that later on. So, the shading is essentially going to be taking what our output is. And why have we got loads of white blobs? That's a bit of an odd one. Seems to be some artifacts maybe in the way I set it up. But our shading is essentially going to take our values from our geometry nodes and use those. So we need 3 attributes that we have defined previously. We have done alpha, we have done the front, and we have done the end, or whatever you would like to call them. So if we just call this alpha, and that type is an instancer, so that gets the instances that are now declared alpha. And the rest are geometry, so we have our end value, our end color, and our front color. They have to be named exactly how you name them in geometry nodes, including capitalization. Just be aware of that. And we're going to have a mix of color, so that should go sort of slightly green yellow. We also need a color ramp. No, not mix color color ramp. And this needs to be this allows us to essentially define this factor, the alpha factor, and essentially tailor it to our needs. But the other thing we need to do is plug in our factor into our alpha first of all, and also plug this into our color ramp. And then finally we need to drag these slightly over here. What we need to do is take our end color, and that goes into slot A, our front color into slot B, and our factor is going to be defined by this color ramp and the alpha. The result of that is going to go through, I believe it's a mix color. Yeah, and we want to multiply, so we actually just want to take these two values and smash them together. I believe multiply is an and, so we want everything, all of the factors put in, and we're going to mix this with a wave texture. Nice wave texture. No, we don't want that in the middle of there. We want a wave texture outside. No, do not want that. I've done that twice now. Let's try that again. Wave texture, right, we want this in the Y bands. Sine, the scale can be brought down. Detail, the rest is fine according to my previous attempt. We take the factor of that, plug that into B. And then finally, this goes into both our base color and our emission. I missed a crucial step. I missed a very crucial step. One which is very important. I did not set my material. Okay, I figured out the problem. There was a slight bug in my process from before, so if you get rid of the random value and the delete geometry, we don't actually need that in this instance. What you end up with is enough geometry to actually form a picture, where we end up with a really, really good effect. So apologies for that. This is, you know, a work in progress. So as pointed out before, I do a little screenshot. There used to be a, well, if I bring them back, delete geometry and random value. So I also scaled the instances separately from the scale in here, but you don't need to do that. So for instance, if we get rid of that, do instance to instance and put that at 140, we'll still be working with the same stuff going forward. So what we had was a probability of 50, and that was just deleting too much geometry. So again, delete that, set the material, bring it to the geometry there, and we have a lot of points. So what you can do just to bring down the number of stuff is again change this value here. The resample curve value is at 200 initially. You also have another curve count here. You can bring that down to like 20, and that will change the number of instances. Or you can bring down, or bring up rather, the resample curve, just to add a bit more spacing in there. That's kind of your values you can change. There are other stuff you can do as well, but essentially that's the full effect. From here, what I would recommend, if we go to 7, which is our top view, and put ourselves on main shading mode, take your world color strength down to 0. That gives you a proper background. You could put in some volumetric effects, but I'm not going to be doing that in this video. What we then do from here is bring in a camera, and if you press Control 0, that brings the camera to your camera view. And as you can see, we get a lovely matrix style code effect going on, and you could in fact take it at an angle, which would give you an excellent, slightly different matrix style effect. What I'm going to do is render a few of these frames just for you to see in the finished result, and I will put that in this video and you'll get to see the final result. If you have any queries, questions, ideas for where this could be used, do shoot something down in the comments. As always, it's much appreciated if people subscribe or give a like to the video, and of course if you'd like a copy of the blend file, I can make that available for people if they would like it. And I hope to see you in the next tutorial.